So if you can see my screen, I'm showing it now. Please just type it in. All right. So in this webinar, I'll be focusing on, like I said, a few things. One of them will be looking at the SolidWorks interface, the ease of use, how we can quickly create new parts and new drawings. We'll then move on to briefly looking at very large or massive assemblies and how SolidWorks can handle those. And then finally, we'll take a brief look at the new costing tool inside of SolidWorks, so how you can get an idea of how much your design is going to cost before you even send it out to a manufacturer or supplier to get a quote. Okay, so let's begin. So what you see on the screen there is a SolidWorks assembly. It's an assembly of a hydraulic rescue spreader. You might have also heard of it called as the Jaws of Life. And these sorts of rescue spreaders are used to basically cut people out of cars when they've been in an accident and to rescue people from, well, I guess what you'd call difficult situations. So at this point, what I'll do is I'm just going to demonstrate some of the SolidWorks interface. So what we have here in the middle is what we call the graphics window, where we see our model. And here we can perform all our actions, so zooming in and out of the model, rotating it around to get a look at different angles. So SolidWorks makes it very easy to see your model from different angles, also to zoom in on a particular region. Moving around, we've got what's known here on the left as the feature tree. In an assembly, it shows the list of components in the assembly, but if you're in a part, it will list all the features. So that a feature might be something like a boss, or it might be a hole, it might be a fillet or a chamfer, and we'll take a look at those when we're designing a part for this rescue spreader assembly. One of the great advantages of SolidWorks is, if we look at the top, SolidWorks has always been developed for the Microsoft Windows interface. So a lot of the familiar buttons and familiar commands that you use in, say, Microsoft Word or Microsoft Excel or any other Microsoft Office application, they all work within SolidWorks as well. So it can be a very handy tool when you're first starting off with SolidWorks to use some of those shortcuts. All right, so like I said, what we've got here is a hydraulic rescue spreader. And if we take a closer look at the inner workings, so I'm just going to hide some components there. If we take a look at some of the closer workings, we can see that there's a missing connection between the arm of the spreader and a hydraulic cylinder here. Even with those additional components hidden, SolidWorks still allows us to test the motion of the assembly. So I can pull out this hydraulic cylinder here. I can move the arm around to test the motion. So what I'm going to do is to design a new part that will basically complete the connection between this hydraulic cylinder and the rescue, the arm of the rescue spreader there. Okay. So let's go ahead and we'll create a new part. I'm just going to click on New, and we'll move into the new part environment. Now, any part inside of SolidWorks is started with a 2D sketch. So I'm going to sketch on the front plane. There's three default planes that are provided along with SolidWorks. We've got the front plane, the top plane, and the right plane. And I like to think of on sketching of each of them as how you'd sketch on the front plane, what your part would look like from the front view. You sketch on the top plane, what your part would look like if you were looking down on it, and so forth. All right, during the demonstration, you might see this little wheel come up that I've got on the screen there. I hope everyone can see that. This little wheel is what's known as mouse gestures. Now, mouse gestures are a great feature inside of SolidWorks. It's another example of how SolidWorks is very customizable. So you can set up all of your most recently or most frequently used commands inside this mouse gestures wheel for much easier access. So for example, when you're in a sketch, if you're sketching circles or lines all the time, you can add them to this wheel so you have much easier access than having to go from the screen up to the toolbars up here all the time. All right, so I'm going to start sketching out the profile for my connection part. So I'll start off by sketching a slot. Drag that out. I'll then sketch a couple of circles. And then I'll sketch a couple of lines. You might notice that I'm not adding any dimensions, or I'm not too worried about the exact shape and size of my sketch as of yet. So one of the good things about SolidWorks is that it allows you to sketch this type of unconstrained geometry and then add constraints and dimensions later on to fully define your shape and size of your model. So now that I've got my basic shape, I'm going to start adding some of those relations and dimensions. So first of all, one of my design goals is that these two circles should be the same size. Now there's various different ways I can do that in SolidWorks. I can add a dimension to both of them. I could add a dimension to one and then make the other circle equal to the other. Or from the start, I can just highlight both of those circles and make them equal. So what this allows me to do is just to add a dimension to one circle and the other one will be automatically updated in size. So I'm now going to go ahead and add some dimensions. So I'll use my dimension tool and add a radius dimension to the slot. I'll then select the two circles, add a dimension to those, add a dimension defining the overall length of the slot, and then finally another dimension defining the overall height. You might have noticed that as I was dimensioning the sketch, the geometry turned from blue to black there. Now that's indicating that SolidWorks knows that this geometry is now fully defined. So it knows where the geometry is lying in space. So now that we're finished with our 2D sketch, what we'll do is go ahead and create a 3D solid from the sketch. Okay, so I'm going to exit the sketch at this point, and we'll use what's known as the contour select tool. Basically select the contours that we want to get into a 3D shape. I'll select those two contours there, and I can simply pull on this arrow, and you can see we get a preview of what our 3D shape is going to look like. So I can, what's known as extrude, I can extrude in one or two directions, or I can even extrude equally in both directions. So I'm going to drag that out to be 50 millimeters. Okay, so there is my first solid, and if we look at the feature tree now, we've now got what's known as a feature. So we've got our first feature, which is the boss extrude, and we've got the sketch that was used to create that feature. So let's go ahead and add some more features to this part. So we've got a fairly sharp corner here where the circular face meets this flat face. So we might need to add a couple of fillets. So I'll start up the fillet tool, and all I have to do is just select the edges. I can set my fillet radius or leave it at the default, and I see the preview of those fillets there. I'll click OK, and I'll add those fillets. With SolidWorks, it's really easy to make changes on the fly. So I can simply select those fillets, and where I've got that 10 millimeter dimension, I can simply drag that out and dynamically change the size of my fillets and get a good idea of what consequences that's going to have on the rest of my design. So I'm going to drag those fillets out to be 30 millimeter radius. Okay, so I also want to add a pocket into, or cut a pocket into the top of this part here. So I'm going to switch to the top view, and I'll start sketching on this top face here. This time I'm going to sketch a rectangle. So just sketch a rectangle, and I'll just add a dimension, make the rectangle 15 millimeters in height. So our sketch is now fully defined. And again, I'll exit the sketch, and we'll use those contours to cut into the shape. With the SolidWorks contours, SolidWorks is intelligent. So it knows if I drag this arrow upwards, I want to add material, but if I drag it downwards into existing material, SolidWorks knows I want to create a cut rather than extrusion. So I'll drag that cut down 40 millimeters. So you can see that was fairly easy, very quick to create. Those corners of the pocket might be quite hard to machine out. So again, we'll add just a couple of fillets to make those edges nicely rounded. We can see that the default fillet radius, which is 10 millimeters, is going to be very large for that particular region. So we can use that on-screen call-out to change the fillet radius to 2 millimeters. All right, so we've got a fillet, have our fillets added there. All right, next I'm going to add a circular boss to the bottom. So I'm going to go sketch on the bottom face there. Again, I'll just sketch a circle, sketch that out, and add a dimension. We'll make that 33 millimeters. Once that's dimension, let's exit out of the sketch, and I'll drag that downwards so to create my circular boss, and I'll drag that downwards for a distance of 50 millimeters. Alright, so we've seen how we can create holes just by sketching circles and cutting them out, but what if we want to add more specialized holes? What if we want to add counterbore or countersunk or tapped holes? Well, SolidWorks allows us to do that with a tool known as the Hole Wizard. So I'm just going to switch normal to that bottom face and start up the Hole Wizard tool. Alright, so you should be able to see the Hole Wizard tool open up here on the left. So the Hole Wizard tool allows you to create counterbores, countersinks, just direct holes, or straight or tapered taps as well. So a whole variety of different holes that you can create with the Hole Wizard. Once you've selected your type of hole, you then go ahead and select a standard to define the type and size of the hole as well. So we've got things like both the ANSI inch and metric standards. We've got the British, German, and ISO international standards, as well as many others in there as well. So it makes it very easy to select a standard size of hole, as you can see here, or define your own custom size for the hole if you wish. So once we've selected the type of hole and the size that we want, all we have to do is then go onto this Positions tab and simply select the point where the center of the hole is going to be. I'll click to place the center of the hole there, click OK, and you can see that my tapped hole has been created, and we've even had some cosmetic threads added to the inside of the hole. Alright, so to finish off this part, I'll add a couple of chamfers. So I can start up my chamfer tool. Now chamfers can be defined by a distance or an angle. I'm just going to define a distance and an angle. So we'll set a distance of 2 millimeters, and all we have to do for a chamfer is to select the relevant edges that we're wanting to chamfer there. I'll select those 3 edges, and we can see that we've had a nice chamfer added to all of the surrounding edges. All right, if we're looking at this at the shaft of the part, we might see that it might be quite hard to machine up where it meets the flat face. So it might be a good idea to add an undercut. Now I could model the undercut myself, but it's a little bit tedious. Might take an amount of time. What SolidWorks allows you to do is, if you've modeled a feature like an undercut or any other feature in the past, SolidWorks allows you to save that feature or the part to the library and then reuse it in any future models. So over to the right here, in my library, I've got a shaft undercut feature. And I'm just wanting to basically drag and drop this onto my existing model. That's what I'll do. I'm going to drag, drop it onto my model there. All I then have to do is to pick a circular edge as a reference for where the undercut will go. And you can see the undercut has been added there. I can then go ahead and change the height of the undercut as I wish. So I'll change that to 4 millimeters. SolidWorks has all these handy little tools that you can use to make your day-to-day design much more efficient. Now, to finish off this part, what I'll do is I'll assign a material. I'll go to my materials, and I'll go into Edit Material. So this will bring up what's known as the SolidWorks Material Library. SolidWorks has a very extensive materials library that you can use to assign to your models. So what we're going to do is, for this particular part, we'll assign the ANSI 4340 steel. So assigning a material to a model in SolidWorks not only changes the appearance, as you've seen there, but it also assigns the relevant material properties. So for example, I can now calculate the mass of this part according to the material that I've assigned. So if I go into mass properties, I've got a mass now assigned to this part here. Alright, so we're finished with the actual design of our part. We want to document this in some way, so I'm going to go ahead and quickly create a part drawing. I'll save this part first. Save it where it needs to go. Add a description, which will come in handy later on when we're creating a bill of materials for the assembly. So now that we've finished our part design, let's go ahead and create a drawing. I'm going to click on Make Drawing from Part. And we choose a drawing template that we want. So SolidWorks has a default drawing template, but you can create your own custom drawing templates to match your own company standards. So for example, title blocks or whatever units you want to create the drawing in as well. So we're now in the drawing environment. So we see a drawing sheet in front of us. And over to the right, we've got a number of views in what's known as the view palette. So the view palette is very handy in that we can just simply drag and drop views onto our drawing sheet. So I can just drag a front view there and drop it onto my drawing sheet, and I can immediately start projecting off standard views as well, saving myself a lot of time not having to drag those views from the view palette. So I've dragged on a front view, I'll drag off a bottom view, a right view, and then an isometric view as well. Okay, so in just a matter of seconds, I've managed to create 4 standard views that I can then go ahead and now start adding more detail to in terms of dimensions. So what I'll do for the isometric view, I'm just going to delete those center lines. And it might be nice to show this isometric view in a more shaded display rather than the standard display that we've got here. So I'm just going to click on the view and click the display to be shaded with edges. So we get the isometric view shown in a nice shaded display. Alright, so we want to add some more detail onto our drawing in the way of dimensions. So because this drawing is going to be used in manufacturing, we'll add some dimensions. Now we could add those dimensions manually, but we can let SolidWorks do a bit of the hard work for us. So all of the dimensions that we assigned in the part environment, we can import those into the drawing environment. So I'm going to start up a tool that's known as Model Items. So Model Items allows us to bring dimensions from our part into the drawing environment as well. So just a couple of clicks and we can see that all of the dimensions that we use to create the part are imported through into our drawing environment. All we have to do then is then go ahead and do a bit of cleanup on those dimensions and add information where we see necessary. I can drag dimensions around and clean them up basically as required. So for example, I'll delete these 2 dimensions here and add a proper chamfer dimension. Then select those 2 edges there and create a proper chamfer dimension, and I can add more information such as we'll type in TYP. Add some more information to that dimension there. We want to add tolerances onto any dimensions. So for example, we've got the circle dimension up here. We can use what's known as the dimension palette. First of all, we'll signify that we've got 2 holes, so we'll type in 2 times. And then we can add a tolerance very easily, so we can add basic, bilateral. In this case, I'll add a limit tolerance. And I'm just going to put in a value of 0.1 there. So you can see very easy to add extra information into your drawing in the way of tolerances as well. One of the, if you're using any sort of 2D software, is that if you make a change to your design, you then have to go and update every view manually where that design is being referenced. With SolidWorks, it has a feature known as associativity, so that if you make a design change in your part, that change is automatically propagated the next time you open up and refresh the drawing. And that works in both ways as well. So if you update a dimension in the drawing, it's updated in the part environment as well. So let's take a look at that. So for example, if I change this dimension here to 40, all of our views are now appear out of date. But if I rebuild the drawing, you can see the geometry automatically updates there. And if we switch back to the part, we can see that the geometry has been updated. Even the tolerances that we added on the circle dimension have been added. So you've got a real-time bi-directional link between your CAD models and the drawings that you're creating from those as well. So you can be confident that any changes you've made have been updated everywhere else that part or that assembly or that drawing is being used. Okay, we'll also change some other dimensions. So I'm just going to change this dimension to 30 millimeters, which is the height of the slot. So if we rebuild that, see the geometry changes. And again, if we go back to the drawing, we can be confident that that dimension has changed there as well. So that's known as associativity between SolidWorks models, SolidWorks parts, and SolidWorks drawings as well. All right, so now that we've finished with the drawing, let's go ahead and save that. And what we'll move on to next is putting that part into the assembly. So let's close down the drawing for now. We've got the part, and what we'll do is we'll switch to the original assembly of the rescue spreader. So we now need to put this part into the assembly. So we'll click on Insert Components, and we can just drag the rod end into the assembly environment. Inside of SolidWorks, when we want to relate parts to each other, we use what are known as mates. So mates are basically 3D relationships used to relate faces or edges of components to one another. So you can, for example, make a face concentric to another circular face, or you can make a face coincident with another face. So let's take a look at how that works. So I'm going to select the circular face of the rod end, hold down Control, select the circular face of the ram, and then click the little paperclip icon, which is the mate tool. And you can see how the part moves in position. If I click OK, I can now move that part back and forwards, but it is concentrically constrained with that circular face there. So I'll add another mate for the position. I'm going to select this edge and basically just drag it onto that flat face of the hydraulic cylinder there. So now the rod end, the part that I've created, is now linked onto the hydraulic cylinder and moves along with it. So it's very easy to add these sorts of mates to define the motion of your assembly. So let's bring in one more component to fashion the link between the arm and the rod end there. And again, you can just bring in components from your SolidWorks library. So you can have libraries of components built up inside of SolidWorks. And I'm just going to drag and drop this link in there. And I just need to make that as per usual. I'm just going to select those two concentric faces there, click Mate, and select the two flat faces there. So it goes into position, and then finally just select the two concentric faces. So I now have a fully functioning link between the arm and the hydraulic cylinder there using the rod end and the link. So I should be able to then move the arm, and you can see it now moves a hydraulic cylinder in conjunction there. So very easy to create fully functional assemblies like that. Now with SolidWorks, when you're moving assemblies, you may often have errors that are only picked up when you come to assembling the your design in the workshop. But with SolidWorks, you can carry out collision detection, interference detection directly in the CAD environment, so you can sort out errors even before your designs get anywhere near manufacturing. So let's carry out collision detection and see if there are any collisions in this assembly. I'll turn on collision detection, make sure I've got stop at collision turned on, and if I drag these faces here, you can see two faces here are highlighted. What this is telling me is that as I'm moving this arm, the geometry that I've got currently is not allowing it to move the arm through its full range of motion. So I need to make some design changes. So what I can do in that point is I can make changes to any part even while I'm in the assembly environment. And because of SolidWorks associativity, I can be confident that those changes are propagated through any drawings that this arm may have or any other assemblies that this arm is being used in. So I'm just going to double-click on that face there. And in this particular case, we've determined that the angle of the pocket is the deciding factor. This is what's not allowing it, the arm to move through its full range of motion. So I'm going to change the angle there from 95 to 120 degrees. I'll rebuild the assembly so we can see the geometry change there. And if we now go ahead and take a look at collision detection again, we can now see that there is no collision. The arm is allowed to move through its full range of motion there. Okay? Obviously, a one-arm rescue spreader isn't going to rescue many people, but we don't have to redo all of the work that we've done here. We don't have to redo it all again. SolidWorks allows us to mirror components over, so we can simply mirror the arm and the link over to the other side of this rod end, and we can save ourselves a lot of work as well. SolidWorks even mirrors the mates that we've added here, or the mating relationships, so we don't have to recreate those as well. So let's take a look at how we can do that. I'm just going to highlight all of these components here, then select the front plane as my mate, as my mirroring plane, and then all I have to do is to click Next, click OK, and you can see my components are mirrored over. So I now have a fully functional relationship between both arms of the rescue spreader there. You can see, as I said, all the mating relationships are mirrored over as well, so there's no need to recreate those on the other side. Let's turn on all of the other components at of the rescue spreader there. And what we'll do is we'll take a look at creating an exploded view, and then finally creating an assembly drawing with a bill of materials. So exploded views are very easy to create. We've got an existing one, we can use that one. So it's simply a matter of selecting components and then dragging them out. So for example, I've got this link here. I'm going to click on it and just drag it out so it's in relative in position to the other link. Same with the rod end. I'll just click on it, drag it out. Finally, this retaining ring here, select that, drag it down so it joins its counterpart there. All right, so there's our exploded view, and we can collapse that at any time, or we can even animate the collapse of it as well. I can click on Animate Collapse, and it shows us basically how the assembly can be exploded and then collapsed back into motion. And you have the option to save that animation out as an AVI or a short video file that you could send to someone for assembly instructions as well. So now that we've created a fully functioning assembly, let's go ahead and take a look at creating an assembly drawing. I'll make a drawing from this assembly, select my drawing template, and as before, I'm going to drag off a view using that view palette, and I'm going to drag on the isometric view. But because we want to show an exploded view on our assembly, all we have to do is simply right-click on the view, and I can just choose to show in its exploded state. And it will basically use the exploded view that you created in the assembly and just import it onto the drawing. What we'll also do, it might be nice to show this isometric view in a shaded state, so we can again change the display style and show it all in a shaded display. No assembly drawing is complete without a bill of materials. So SolidWorks has a standard bill of materials template that will display all of the relevant information in your assembly. So let me go ahead and create a bill of materials. With just a couple of clicks, we have a comprehensive bill of materials that's created, which displays all of the components in the assembly, along with their relevant quantities. The beauty of creating a bill of materials inside SolidWorks is, again, because of that associativity, if you happen to go back to the assembly and add or delete any components, next time you come over to the drawing, your bill of materials will be automatically updated as well. Now, with bill of materials, you can see that item numbers have been assigned to items within the assemblies. Those item numbers aren't going to make much sense without having some balloons that point to the relevant items in the drawing view. So we'll select the drawing view again, and we'll use what's known as the auto ballooning tool to add balloons to the assembly there. Let's just drag those in. What you might notice as well is that the balloons here are out of sequence, but we can choose to order them sequentially as well, and even choose which item we want to be the first one. And your bill of materials will be updated in order to reflect the balloon order there. All right, so let's just do a little bit of cleanup on those balloons. So I'll just drag those into the drawing sheet view. So we have our balloons, we have our bill of materials. one last thing that I'll do to finish off the assembly drawing is that the assembly drawing, obviously because it's a rescue spreader, it has jaws that can open and close. And it might be nice to show that sort of functionality on the assembly drawing for whoever is going to manufacture and assemble this rescue spreader. So what I'll do is I'll drag off, or drag on rather, the top view of the rescue spreader. So that's how it looks there. So that at the moment the jaws are in the closed position. What I'm going to do is create what's known as an alternate position view, so we can show the open jaws on the same view without having to recreate another view. So we might have a situation where we have limited drawing space on our sheet. So that's why we can overlay views on top of one another to show whatever functionality is present in our design. So you can see that we're showing both the open and closed configurations of the rescue spreader. Finally, to finish off, I'll just add a couple of dimensions just for overall size, an overall height dimension there, and an overall length dimension there as well. And that is completing our assembly drawing. So, so what I've shown you there is how easy it is to create a new part, create a part drawing, importing in dimensions, putting a part into an assembly, bringing in components, adding those sorts of mates, and then finally creating an assembly drawing complete with a bill of materials and a balloon, and finally how you can show various functionality in the same view on your drawing as well. So what I'll do now is I'll move on to how SolidWorks can manage those massive assemblies as well. So before I do that, I'll just save and close this drawing. Close that down. And let me switch to another window where I've got a fairly large assembly open. So I hope everyone can see that on the screen. So this is an assembly of what's known as a crusher house. So it is a very massive assembly indeed. I think the total length is something like 200 meters from end to end. So with very large or very massive assemblies like this, SolidWorks has a number of tools that can help you to work with these assemblies quickly and effectively as well. So one of them, the one I'm using at the moment, is what's known as the Large Design Review. The Large Design Review allows you to open up massive assemblies like this very quickly and very easily, and still do all of the functions that you would do in a normal assembly. So you can still spin around, you can rotate, you can open up other components of that assembly, so you've still got access to what we call the feature tree, and you can go ahead and open other assemblies for further design work as well. So we can open up the chute for the crusher house and carry out any design work if we had to. Okay? With the massive assemblies, often you need to create custom views or custom angles for ways this assembly is best viewed. So we can create what are known as snapshots. We can even add comments to those snapshots. So for example, we can look at a close-up of the big assembly, and we can check for clearances or anything that we need to there, or take measurements. We can even create section views in these big assemblies as well. So I've created a section view there, and it seems to have cut that poor human figure right in half. But as I was saying, in your section views, you can still take measurements. So for example, I could take a measurement between that face there and the bolt head, just to see if there's enough clearance in this particular case, so that do I have enough clearance to get a spanner in there to carry out any maintenance on that bolt should I need to in the future. If not, I might need to go ahead and make some design changes. So large design review or large assembly mode allows you to look at the very small detail, but in relation to a very large assembly. One of the other great tools that's good for visualizing very large assemblies like this, if we just go back to the start, is what are known as creating walkthroughs. So you can create a walkthrough or an animation that shows basically the ins and outs and more, I guess what you'd call more smaller details of your assembly. So I've got a walkthrough here. I'll just go ahead and edit that and we can take a look at playing the recording. So I hope everyone will be able to see the recording. I apologize if you can't, so I'll click and play it now. I hope everyone can see that. And you can see with the walkthrough, they're very easy to create, and we can get a much better in-depth look at large assemblies. And you can, these are great to use for any sort of sales or marketing presentations as well. So that was just a very brief look at how SolidWorks has various tools to handle large or massive, particularly massive assemblies, just like this one. All right, so the last thing that we'll look at in this webinar is what we call the costing tool. So we can get an idea of how much our designs cost before we even send them out for a quote. So let me switch to another part here. So what I've got here is a standard design for a bench. So the bench is made out of some sheet metal parts as well as some solid parts like the feet there. So I'm going to start the costing tool. Start that up. Now, how the cost is calculated is that you select, first of all, what parts of your design you want to cost. So, for example, in this particular design, the 2 feet of the bench are to be made from a casting process rather than a fabrication process. So I don't want to include them in this cost estimation. So I'm going to select both of those cast feet and choose to exclude them. Then I get a message that I can begin the cost estimation. So the way costing works is that you set up a costing template in which you assign costs to various features, various setup costs, labor costs, machine rates, things like that. Based on the costing template and the features that you've got in your design, SolidWorks costing will come up with an overall cost for your design. So I'm going to begin a cost estimation. It'll take should take about a minute or so. We'll calculate basically the cost for each body in this design and then come up with an overall cost. All right, so I hope you can see down here at the bottom right, it's calculated a cost for the part or for the design. One of the great things with costing is that it allows me to test out various designs by first setting a baseline cost and then changing my design to see how that's going to affect my cost. So at this point, what I'll do is I'll set a baseline. So this is going to be my very base design. And then I'll add or remove certain features and see how that affects the cost. So say, for example, I want to add a logo to this bench. So I can go back to my feature tree. I've got the list of features. I've got one down here called the logo, and we'll add that in and see how that affects the cost there. So it adds in the logo, and I can get a click to update, so I can update that. And we should get an updated cost. Right, shouldn't be too long. So there we go. So we've now got an updated cost. It's telling us that it's going to cost slightly more because obviously we've got additional cutting time to cut the logo out of your sheet. So there's obviously additional machine costs, additional labor costs, which all adds up. So it's telling us it's going to cost slightly more to add in the logo as well. We can get even more in-depth and add more detail into our costing by adding custom operations as well. So we can figure out, or we can set up costs for, say, how much it's going to cost to paint this, or anodize this, or perhaps maybe weld it as well. So I can add in a cost of painting, and we'll see how that affects the cost as well. So we can see whatever material that we've assigned for this part, based on that material and based on the weight of that material, it's going to cost that much to paint it as well, and you'll get an updated cost. You can set up as many costing templates as you like as well. So one reason why you might do that is you might have different costing templates for different suppliers or different manufacturers who may give you different quotes. So you are able to set up those different costing templates and get a great idea or great estimation of what one supplier is going to quote to get that part manufactured and what another one is going to quote as well. Finally, when you're happy with your cost estimation, you can create what's known as a costing report as well. So this is a handy report based on a standard SolidWorks format, and it comes in the form of a Word document. So just bear with me for a couple of seconds while it generates that report. All right, so if I open up the Word document now, so you can see it's a fairly easy to follow format. It takes in all the information from the part, such as the name, the date, whatever, the weight, the total number of parts that you want to produce, the estimated cost, also as a comparison to the baseline, and it also gives you a comprehensive cost breakdown as well. So it gives you a high-level overview, as well as the breakdown in terms of material and manufacturing, as well as what features or parts of your model cost the most or cost the least. So you can then take a look at this and then go back to your design and maybe make changes to reduce the cost where possible. So whenever you have costing at a design review or anything like that, you have a report there ready for you to go, so that you can present the cost of your designs there. Okay, so that is all I had to show in this webinar. So thank you very much for your time and attention. If you have any questions at this stage, please do type them into the questions box there, and I'll try to answer them obviously as much as possible. So thank you very much. So we've got a question, is the size of a design piece limited by the environment of complete drawing? I'll take that to mean by how big can you show the views on the drawing. I hope that's correct. You can set up the drawing template to basically reflect the size of your model. So you can change the scale of a view once you get it into the drawing environment. So you can show it either 1:1 or 1:5, whatever is based on the drawing. And you can set up different drawing sizes. So you can set up A3, A4, A2, A1, or any sort of custom drawing size as well. So I hope that answers your question. If not, clarify a bit further. So I'll leave the questions window open for another 10 minutes or so. So if you do have any questions, please do type them in. Someone else has asked if we can have the video of this tutorial. I have recorded the webinar, so I believe we will be able to provide